Hi, I'm Lydia and I'm solving video solution number 3. So this problem has us take a situation where we're playing a dice game and you win $5 if you roll a 5 or a 6, you lose 4 if you roll a 1, and you lose 3 if you roll anything else. And in the situation, X is the profit in one play. So part A asks us to find the probability distribution for X. So if X is the profit in one play, we'll start with the $5. This is our X column, and then this will be the probability of X happening. So to get $5, you have to roll a 5 or higher, so that would be a 5 or a 6. And there are 6 possible outcomes on a 6-sided dice, so this is 2 out of 6 is the probability of it happening, because there are 2 numbers out of the total you could roll. The next amount you can lose is $4, so this is -4, and to do that you have to roll a 1. So out of the 6 possible outcomes, that's 1 outcome. And then the third option is to lose $3, and that's if you roll anything else. So that would be a 2, a 3, or a 4. Those are the only numbers left that aren't in these other 2 options. So those are 3 out of the total 6. So these are the possible profits and the probability of them happening. And then part B says to find the expected profit from playing this game one time. So to find the expected profit, we're going to take X times the probability of it happening. So we'll do, for the first one, it'll be 5x times the possibility of it happening, 2/6. And then we'll add on -4. The probability of it happening is 1 out of 6. Plus -3 times the probability of 3/6. And this comes out to 1 2/3 minus 2/3 minus 1.5, which equals about 0.499. So the expected profit from playing this is actually to lose about 50 cents. So then part C says find the standard deviation for playing this game. So to find standard deviation, we'll first take x squared times the probability of it happening. So we have 5 squared times 2/6 plus -4 squared times 1/6 plus -3 squared times 3/6. And this comes out to 8 1/3 plus 2 2/3 plus 4.5, which is 15.5. And then we're going to subtract the expected amount squared, which is the same as the mean. So the mean, or the expected profit squared. So that was our 0.499, which squared is, I'll just write it, 0.449 squared. Is what we're subtracting from 15.5. So it's 15.5 minus 0.25 equals 15.25. And this is our variance, but we're looking for standard deviation, which is the square root of variance. So if we take the square root of this, we get our standard deviation of 3.9051.